Today's video will deal about solving systems of linear equations in two variables. And first we're going to use the determinants, and then we're going to solve this one by the usual method. So for the determinants, we first get the determinants with respect to the constant here, 7 and 2. So that will be equal. We get the matrix here, 3 and -5, and 1 and 1. So that one is 3 minus 5 is +5. So that is equal to 8. So for x, always remember to substitute the value of the constants here to the coefficients of x. So this one, dx, instead of 3, we'll use 7 and -5 here, and also 2 and 1. So that will be equal to 7 minus 10. So 7 plus 10. So that is equal to 17. So for y, dy, d's of y. So just the same, we replace the value of y, the coefficients of y, by 7 and 2. So we have here 3 and 7, and 1, 3 and 7, and 1 and 2. So that will be equal to 6 minus 7, and that is equal to -1. To get the value of x, that will be equal to dx over dc. So 17 over 8, and the value of y is dy is -1 over dc, which is 8. So these two are our answers. So to verify our answer, we try to solve for the solution of this by the usual method. Usually we get here 3x minus 5y is equal to 7, and then we multiply the second equation by 5. So this one is 5x plus 5y is equal to 10. And then we add so that we can get rid of the variable y. With here 8x is equal to 17. So x will be equal to 17 over 8. So we're getting the same answer for this. Getting the same answer. So for the value of y, we just substitute the value of x here to this equation 2. So 17 over 8 plus y is equal to 2. And y is equal to 2 minus 17 over 8. And that is equal to 16 minus 17 over 8. And that will be equal to -1 and over 8. So we are also getting the same answer for the value of y. No? If you will notice, the solution for this equation here by the usual method is much longer, no? By using the determinants. So we go to the next, no? To get more, to understand it more, we'll have another sample here. So we'll erase this now. So for our sample number 2, we have here 8x minus 4y is equal to 8. 8x minus 4y is equal to 8. And x plus 3y is equal to 22. X plus 3y is equal to 22. So dA of C, the matrix, will be 8 and negative 4 and 1 and 3. So that will be equal to 24 minus 1 is 4 is plus 4. So that is equal to 28. For dx, again, we substitute the value of the constant here to the value or the numerical coefficients of x in the equations. So we have here, so happen that the value is the same as the constant. So we have here 8, 8, and 8. No? 8 and 4. 8 minus 4. And 22 and 3. No? So that will be equal to 24 minus 88. No? Minus 20. So that will be equal to positive, so 112. 112. So dy here, again, we'll place the value of the constant to the value of y. So 8 minus 8 and 8. And 1 and 22. So this one is 176 minus 8. So that will be equal to 168. Again, for the value of x, for the value of x here is dc over dx over dc. So that will be equal to 112 or dc is 28. So that's equal to 4. Okay. So y, for the value of y, is dy over dc. Dy here is 168 over 28. So that is equal to 6. So here, we're going to solve this equation by the ordinary way, ordinary method. We multiply equation 2 by 8 so that we can get rid for the value of x here, for the variable x. So we have here, we write again 8x minus 4y is equal to 8. Multiply equation 2 by 8. So we have here 8x plus 24y is equal to 176. No? So subtract, no? We subtract. So what will happen here? Cancels out this one, and negative 28 is equal to negative 168. Y, no, that's y. So y is equal to 6. So if we have the value of y here, substitute in equation 2, no? So we have here x plus 3 over times 6 is equal to 22. X is equal to x plus 18 is equal to 22. X is equal to 22 minus 18, and that is equal to 4. So we're getting the same answers, and as we go along, we'll conclude that the method using the determinants is much more simpler, and we can, even in the in more complicated problems like 3 variables and 4 variables. So again, I enjoin you to please watch my videos in my YouTube channel, and don't forget to subscribe. That is my video in by Wilfredo Tan. So thank you for watching, and see you again later.